Hello, I'm Michael L. with Empowered Networks, the network intelligence experts. In our last video, we talked about the importance of NCCM to a strong network intelligence practice and enumerated the capabilities that make up an NCCM solution. Today, we're going to drill down on some of these capabilities, specifically discovery, inventory, and topology. We'll start with discovery, which is the capability to find the devices that the network is composed of, as well as those devices that are connected to the network. A common first attempt at this is ping sweeping the entire address space, but as a discovery strategy, sweeps alone are both insufficient and impractical. Many devices simply don't respond to common inquiries, such as ICMP pings. And in the case of IPv6 networks, the sheer volume of addresses which would need to be tested makes it infeasible. For discovery to be effective, it must leverage neighbor data. This comes from a number of sources, including CDP, LLDP, and ARP tables, as well as API queries against controllers in the case of SD-WAN solutions and cloud providers. Once discovery is complete, we move into the inventory stage, where as much information as possible is collected from the discovered devices. Collection of this data happens via a number of different mechanisms, including SNMP and command line for legacy devices, while mainly API-driven for modern infrastructure. The information collected should include detailed features associated with the devices themselves, components such as cards and interfaces, serial numbers, firmware versions, as well as configuration, the use of which we'll delve into more deeply in our next video. In addition to its role in discovery, neighbor data should also be leveraged to construct a topology describing the relationship of the various discovered devices to one another. This is useful both for visualization, as well as providing a source of data for a multitude of other uses, including service mapping and impact analysis. The use cases aren't limited to operational capabilities either. Being able to quickly identify devices and their locations on the network can help security teams respond efficiently and accurately, saving time when they need it most. This topological data should be derived from discovered data, not manually created. Dynamic updates ensure its accuracy and usability in further analyses as the network evolves. It should also be layer-aware, as well as handle abstraction and partitioning, such as occurs with VRFs and VLANs. One thing to keep in mind is that although people tend to think of discovery as a process carried out by a single program, most organizations actually have multiple different tools carrying out discovery activities. There's a lot of power in being able to pull the information from these various discovery sources together to maximize the overall coverage, internal consistency, and improve their associated network intelligence. Finally, while it's great to have discovered and inventoried all of this information, it cannot truly support a network intelligence practice if it cannot be leveraged. That means being able to easily access the data via a complete and responsive RESTful API. In our next video, we'll dig deeper into the uses of the configuration data that we have collected from our devices and some associated best practices. Thanks for joining us today.